Hi, in this video we're going to take a look at how to solve basic logarithmic equations. We usually follow this procedure. If we have multiple logarithms, we're going to combine them together. Be sure that the equation is going to end up being with a logarithm on one side and a number on the other side. We're going to rewrite that in exponential form, solve the resulting equation. It's very important that you check solutions. Remember, a log cannot have a negative value in it. So the values need to work out in such way so that everything is going to be non-negative inside. Start with these very basic ones. Log base 2 of x equals 4. Well, rewriting that in exponential form will be x equals 2 to the power 4, which means x equals 16. There is no issue here with anything being negative. That is our answer. This problem, same idea, x equals 3 to the power negative 2, x equals, that's going to be 1 over 3 squared, that's 1/9. No issues with anything being negative inside a log. 1/9 is going to be our answer. Okay. This problem, so we need to get rid of this 5, so we need to, because we want to leave the logarithm by itself. We'll subtract 5, it should be pretty easy. We're going to get log base 1/2 of x equals negative 6. Now we can switch it into exponential form, which is going to be x equals 1/2 to the power negative 6. That is going to give us 64. Nothing's going to be negative inside of a logarithm. We are fine with that answer. 64 it is. This problem, so let's start by subtracting 3 so we can leave the log by itself. So log base 5 of 3x plus 1 equals 2. Now log on one side, a number on the other side. Switch it to exponential form. 3x plus 1 equals 5 squared. So 3x plus 1 equals 25. And you can solve this equation. You can find that x is going to be 8. If you substitute 8 in here, you're going to get a positive number. That is, and everything's fine. And that's the answer. Alright, so this problem here, first of all we want to get rid of this 1, so we add 1. So we have 2 log base 4 of x equals 2, right? Oh, I'm sorry, that's going to be 4. 3 plus 1, of course, is 4. So what do we need to do now? You see it's 2 times the log. We need to get rid of that 2. That means log base 4 of x equals 2. And now we can see that x is going to be 4 squared, which means x is 16. No problem with a number inside of log being negative. 16 is going to be the answer. Now we have these problems, like example 6. So you have a log plus another log. You need a single log here. You have a number here, but these two logs need to be combined. So using properties of logarithms, we can actually remember, I hope, that you can get these two quantities multiplied and convert into a single log. So what do we have here? This is base 10 log, right? Because it doesn't have a base explicitly written. That means that x minus 1 times x plus 2 is going to equal 10 to the first power, which means it's x squared plus x minus 2 equals 10. It's a quadratic equation, which means we're going to need to bring all the terms on one side. Our quadratic equation in this case in standard form is going to be x squared plus x minus 12 equals 0. We continue here. So we can factor it. It's going to be x plus 4 times x minus 3 equals 0. And we have x equals negative 4 and x equals negative 3. So let's check this now. For negative 4, if I substitute negative 4 in here, I'm going to get negative 4 minus 1. That's negative 5 right here. That is not going to work. And it's also not going to work here for the same reason. Negative 4 plus 2 will give you negative 2. You cannot use a negative value inside of a log. So this one, oh, I'm sorry, that was positive 3. So negative 4 is going to be what we call an extraneous solution, and we're going to have to reject it. Do we have any issues with 3? 3 minus 1 is 2, positive. 3 plus 2 is 5, positive. 3 is good, and that is our answer. This is exactly why you must go back and check any solutions that you obtain in the original equation. Okay, let's move on. So number 7. This is a similar situation. We have two logs that we're going to need to combine. This is a difference, so that's going to become a quotient. Log base 2, x minus 2 over x plus 1 equals 2. Rewriting that in exponential form will be x minus 2 over x plus 1 equals 2 to the second power, so x minus 2 over x plus 1 is going to give you 4. It's a relatively simple rational equation to solve. You multiply both sides by x plus 1, so you're going to have x minus 2 equals 4 times x plus 1. X minus 2 equals 4x plus 4. Alright, so when you are done solving this equation, you are going to get that x equals, well, we're getting what? We're getting 3x equals negative 6, x equals negative 2. So can we use negative 2 in the original equation? Well, right here, negative 2 minus 2 will give you negative 4. That is not good. So this is an extraneous solution. It's the only one we have. We're going to have to reject it because it does not give us a positive value inside of logarithms, and so the answer here is going to be no solution. This problem, we have to solve this. We have 3 logarithms, so we have this plus that. You multiply these two quantities and minus that, so you're going to divide. So let's first of all rewrite that. So what we're going to get is log base 3 of x plus 1 times x plus 18 on top divided by x plus 2 on the bottom, and it's going to equal 2. A single logarithm equals a number, so we're going to get x plus 1 times x plus 18 divided by x plus 2 equals 3 squared, which is going to give us 9. Multiply both sides. Make sure you can clearly see what I'm going to do next. You're going to multiply both sides by x plus 2. And that is going to result in giving us, so these two will cancel. I can FOIL this. That's going to end up giving you x squared plus 19x plus 18 equals, on this side we distribute 9x plus 18. Okay. After you, since it's a quadratic equation, you move all the terms on one side. You're going to get x squared plus 10x equals 0. So we can factor out x. It's going to give us x times x plus 10 equals 0, which means x is 0 or x is going to be negative 10. And what's going to happen now? Does 0 work? Take 0. 0 plus 1 is 1, positive. 0 plus 18, 18 positive. 0 plus 2, positive. 0 is fine. How about negative 10? Negative 10 plus 1 is negative 9, negative. You don't even need to check the other ones. As long as one of them gives you a negative value, doesn't matter what happened with the other ones. So x equals negative 10, we'll have to reject that. And our only solution here is going to be 0. Okay. I have a couple more. These are kind of slightly different. This is when you have a log on one side and a log on the other side. So these are in the way easier to do, and that's what we're going to look at. So 1 log with base 5 on one side, log with the base 5 on the other side. That means that these two quantities are going to equal. So we can conclude that 2x minus 3 equals x. Right? So that means x is going to equal 3. Do we have any problem with 3? Well, clearly not here. When you substitute 3 in here, 2 times 3 is 6, 6 minus 3 is 3. No problem. 3 is a good answer. So here we have 2 logs, which means we're going to have to combine them together. So it's going to be log base 6 of x plus 4 times x plus 2 equals, here we have 2 times log. So we can't have a number in front of that, and properties of logarithms allow you to take a number, a constant multiple like this, and bring it here as an exponent. So that means this side is going to be log base 6 of x squared. And now you can go ahead and get rid of the 2 logarithms. So what do we get here? We're going to get x squared plus 6x plus 8 on this side. On this side, we're just going to get x squared. Correct? X squared is going to end up canceling. You're going to get 6x plus 8 equals 0. And if you solve this equation and simplify the answer, it's going to give you x equals negative 4/3. Do we have any problems with negative 4? Right there. If you go with negative 4 in here, you get a negative value. It's the only number we have to reject it, and the answer here is going to be no solution as well. Okay? And I hope this was helpful.